Just a quick reminder, you probably heard this before, but all equations can be solved using a graphing calculator. If you just graph it and whatever it looks like, if you find out where it crosses the x-axis, that's a solution. So if that was -2 where it crosses, -2 would be a solution. But we're not going to be cheaters today. We're going to solve this with an algebraic method. If you look at it, it might ring a bell to something you've done before. It's a trinomial. Usually it's x squared, x, no x. But if you let, instead of saying x squared, x, no x, if you think x squared is the variable that starts off those parentheses, you can factor this like you do a normal trinomial. Because look, if I start off two parentheses with an x squared times x squared will make x to the fourth. That part's covered. And now I just need to find two numbers that multiply to be -90 and add it to be 1. And those are the pieces that are going to go in there. So how about a +10 and a -9? Those multiply to be -90. Those add up to be +1. But this piece right here can be factored further. It's one of those perfect trinomials. Sorry, it's not a trinomial, but it's one of those perfect expressions where you can factor it and make one be a plus, one be a -3. That way, when you multiply these two parentheses out, the middle term cancels. That's why we don't have that little the x there. But I found two numbers that multiply to be -9, and that were the same. That way, I'd cancel out and have a middle and have no middle term, which is missing in that binomial. So this is the factored form of this. And this would be our final answer. Oh shoot, sorry, we were asked to solve. That's not our final answer. Factoring though helps us solve because you take each factored piece and set it equal to 0. Because if x squared plus 10, if we manage to make that equal to 0, then we're going to have a chain reaction. And this 0 that this is all going to equal will distribute and make everything else be 0, giving us a true statement. So that's why setting it equal to 0 is important. So we'll take this one and set it equal to 0, and we'll take the last one and set it equal to 0. And we'll solve all three. So the middle one, it's pretty clear. If you plug in a -3, it'll be 0. Same thing with the bottom one. That one's pretty clear too. But let me do this one step by step just in case you haven't seen it before. This is a type of quadratic where you can actually get x by itself. If you subtract 10 from both sides, you get x squared equals -10. And then you want to get x by itself, so take a square root of both sides. Every time we use a square root to cancel out a squared, we got to remember it's positive or negative of whatever our result is. And then whenever you're trying to take a square root of a negative number, you got to factor out an I. So that's square root of 10i there. And that's actually it. There's two answers there: a positive square root of 10i and a negative square root of 10i. We got two answers here: a -3 and a +3, and that meets the conditions of the fundamental theorem of algebra, saying that the highest power of a polynomial dictates how many solutions you can find. We found 4, so those 4 that we just mentioned.